Good morning, grade 7, and welcome to another beautiful day in sunny South Africa. Yes, we are blessed by this amazing weather, and I hope you are getting to spend some time outside and grab a little bit of vitamin D. As you all know, today is Earth Day. Yes, Earth Day. So I'm going to start off with my lesson with some very wise words from a colleague of mine, and I want to share them with you. So listen carefully. Right, so it's called Covert Courage, and it goes like this. I can choose my way of looking. I can look up or I can look down. I can see nothing or I can see more. I can glance back or I can focus forward. I can look inward or I can share outward. I can see a future and I can see a hope. And grade 7s, I wanted to start my lesson like this today because Earth Day is important to me, and I want us to have hope for the future, for our planet, for our Earth, and for us as the human race. So let's get started. Today's lesson is acids, bases, and neutrals, and we are looking at lesson 2. And for those of you who don't know me, I am Mrs. Hall. So the Earth Day 2020 report is looking fabulous. We've got less industrial pollution, less air pollution from cars and aeroplanes. We've got less noise pollution at airports, and we've got way less litter on the streets. And all it took was a global pandemic shutdown. Yes, Earth is healing. Earth is taking a break. Look around you. Look at the animal life. Go onto websites and look at those video cameras that are catching the most amazing footage of animals reclaiming their land. The birds on the beaches and what's happening in the mountains. All the little animals are coming out of their hidey holes, and if their camera is set up, wow, what an amazing sight to behold. So, Earth Day is celebrated every year on the 22nd of April, that's today. Worldwide, more than 170 countries will host rallies, outdoor events, and conferences to get the green message out. This year, I think it's going to be mostly virtual. Look out for those virtual websites where you can participate in Earth Day. The very first Earth Day was celebrated in 1970, following the devastating 1969 oil spill in California. It was hoped that the day would inspire people to learn more about the environment, and it worked brilliantly. In 1970, Earth Day was limited to the USA, but a team of dedicated people behind it was able to inspire around 20 million people to get involved in protests, rallies, and discussions. So yes, grade 7s, become more involved. Take an active interest and participate in what's happening around you. Our lesson objectives for today are as follows. Following on from acids and bases yesterday, we're looking at the pH scale. We're looking at chemical indicators, how to classify solutions which are acidic, alkaline, or neutral using pH values, and we're looking at neutralization and common uses. Let's start with what is a pH scale. A pH scale is used to measure how acidic or how basic a substance is. So the pH scale ranges from 0 to 14 with a neutral pH of 7, directly in the middle. So the pH scale is used to also express the strength of the acids and bases. So, like I said, ranges from 1 to 14. Acids have a pH less than 7 going this way, and they become increasingly acidic to the left. Bases have a pH more than 7 and they become increasingly alkaline to the right. And neutral solutions have a pH of exactly 7. So chemical indicators are substances used to measure or indicate the pH of a substance. Perhaps the best known pH indicator is litmus, which actually comes from a plant called lichen. There's also thionyl blue, phenol red, and methyl orange, and they're all common acid-base indicators. But red cabbage can also be used as an acid-base indicator, and if you were in class right now, your teacher would have got you to make this incredible indicator. Yes, it's a science cabbage. So red cabbage juice is considered to be an indicator because it shows us something about the chemical composition of other substances. So red cabbage contains a water-soluble pigment called anthocyanin that changes color when it is mixed with an acid or a base. Let's take a look at how we make red cabbage chemical indicator. So let's follow the procedure. You chop the cabbage into small pieces until you have about 2 cups of chopped cabbage. You filter out the plant material to obtain a red, purple, bluish colored liquid. And you all know how to filter now. You've learned that in your previous lessons. You pour about 50 to 100 ml of your red cabbage indicator into each 250 ml beaker or glass jar or just a glass at home. You add various household solutions to your indicator until it changes color. So, what color do acid-base indicators change to? As I said earlier, litmus is a plant extract. Can you remember the name of the plant? Yes, lichen. That can be blue or red or pink. That's the color of the indicator. So litmus turns a red or a pink in an acidic solution. So a good way to remember, acid is red. Acid is danger. So think acid, think red, right? And then litmus turns blue in a basic solution. So your base is blue, B and B. Okay, so you can look at acid being danger, red color, or D and D, or base blue, B and B. Easy way to remember, grade 7s. So we have red litmus paper and blue litmus paper. And it's very important when doing the test that you use 2 pieces of paper, one red and one blue. And I'll explain why now. So red litmus, when put into a substance, will turn blue if it's dipped into a base. However, red litmus will stay red if it's dipped in an acid or a neutral. Blue litmus turns red when dipped in an acid. Remember, acid always goes red, and blue litmus stays blue if dipped in a base or neutral. So blue stays blue. Right. Now, why is it so important that each substance gets tested with a red and a blue litmus paper? Obviously for accuracy. And when working with neutrals, okay, red will stay red in a neutral and blue will stay blue in a neutral. And it's easier then to see if the substance is a neutral as well. So let's take a look over here at our science experiments that we've put onto a slide for you. If we were in class, this would all be practical. It's such a lovely practical lesson because we bring all of our substances from home and we test them in the laboratory. So here we have an unknown substance in a glass beaker. I have a piece of blue litmus paper and it's changing color. So what is happening there? What is this substance over here? And over here, I have a beaker filled with a different substance, and I'm using red litmus paper, and there's a color change that's happening over there. So you should already now know what is happening with these substances and which is an acid and which is a base. So this litmus paper that was blue turned red. So this substance is an acid. Okay, we know litmus paper turns red when dipped in an acidic solution. Okay, and in this substance over here, we had red litmus and it turned blue. And straight away we know blue is a base. So it turns blue in an alkaline solution. I hope this is making sense to you. It's always good to go back and play the video again or rewind and just consolidate if I went a little bit too quickly for you. I hope not. So another chemical indicator we use in the science lab is called pH paper. And a pH paper also changes color to indicate the pH of a substance. Okay, so here we have some pH strips. If you look closely, you will see they're not the same color as litmus. They're just a simple plain color. Okay, so here we have a pH indicator, and what I'm going to do is I'm going to put some different solutions out, and we're going to dip the pH paper into the solution, and I'm going to ask you, what is the pH of A? Over here, looking at your pH scale, right? Remember, 7 is neutral, to the right is alkaline, to the left is acid. So A, very distinctly, on this side of the pH scale, it is an acid. B, okay, looking over here, comes in over here, it's on the left-hand side of 7, so I would say it is also an acid. C goes to the right-hand side of your neutral, so C would be a base, and D very distinctly also a base or more alkaline. Just remember, an alkaline solution is a base that can dissolve in water. Right, so look at this pH indicator paper. Here's our indicator paper. It always turns red in an acid. It turns green or a greenish color in a neutral, and blue in a base. So whether you are using litmus paper or pH indicator paper, it still has the red color or the blue color. A pH indicator shows you how dangerous a chemical is by changing color. Now remember, yesterday we spoke about acids being corrosive. They can burn through materials, okay? The pH indicator changes color to show the pH, the acidity, or the alkalinity of the substance, rather than how dangerous it is. Although some acids can be very dangerous, there are still acids that we use every day. We spoke about them yesterday. Household acids like vinegar, found in, obviously, vinegar, and citric acid, which is found in your citrus fruits. Alkali can burn you, and do you know that they often cause more harm than an acid? Interesting. Alkalis are more caustic. Acids always turn red, and alkalis turn blue or purple. This is the case with universal indicator. Other indicators may only show the presence of a certain range of pH and might not show the same full color spectrum. Neutralization, we spoke about it yesterday. It is when a chemical reaction occurs when you mix an acid and an alkali. A neutralization reaction occurs when they are combined in proportions that result in a product with no acidity or alkalinity. They cancel one another out and produce a product that has a neutral pH over here. Who can remember what the perfect pH of a pool is? I told you yesterday. I hope you did your homework. 7.2. Right. Acids and bases are two special kinds of chemicals that you've learned about now, grade 7s, and almost all liquids are either acids or bases to some degree. Whether a liquid is an acid or a base depends on the type of ions in it. Now you're going to learn about this next year. If it has a lot of hydrogen ions, then it is an acid. And if there are a lot of hydroxide ions, then it is a base. There are many strong acids and bases in nature. Some of them are dangerous and used as poison by insects and even by some animals. Some are helpful to us though. Many plants have acids and bases in their leaves, seeds, or even their sap. Citrus fruits like lemons and oranges have citric acid in their juice, and this is what makes lemons taste so sour. Right, as I said earlier, substances near pH 7 are neutral, and we also get neutral substances. And that is why when testing with litmus paper, always use 2 pieces, because in a neutral substance, red will stay red and blue will stay blue. Okay, so neutral substances are things like pure water, salt and sugar solutions. So if you mix salt and sugar into water, it is neutral, and even cooking oil is neutral. So wasps, ants and bees, let's take a closer look at them in nature and how it affects us from an acid-base standpoint. So females usually have an ovipositor, which is a long, thin, hollow structure used to lay eggs. However, in some species, this tube has developed into a sting with a gland at its base, which will inject a toxin into the victim when the insect is provoked. In insects like wasps and bumblebees, there is a smooth sting with no barbs, so it can sting repeatedly. Interesting. Other bees, such as honeybees, have barbed stings, and this breaks off in the victim when it penetrates, and that's why the bees die. Unless allergic to the sting, most humans will find these stings painful, but not a danger to your health. Me, I'm a little bit of a baby with a bee sting, I must be honest. For ants, their stings squirt an acid called formic acid into their victim. And yes, we get ants that sting. There you have a picture of a hornet sting and a hornet. Now, the reason I put these little critters in is because do you know that there are people, if you are attacked by a swarm of hornets, they are actually so poisonous that they've actually killed people. It's quite scary. So if ever you're in a situation where you're being attacked by a swarm, the best thing is to jump into a pool of water and stay under and just come up and breathe when you need to, so that they can't get to you. So bee and wasp stings can be both painful and itchy, and are very common during summer. So some of us are quite scared of wasps. Luckily, I haven't been stung by a wasp in a long time, but I remember as a child just how painful it was. Fortunately, there are easy ways of neutralizing these toxins that these stings deliver and reducing the pain. Many common household substances can be used for this, like vinegar and baking soda. Now, this is quite interesting. Wasps and hornets are basically the same, differing slightly in some aspects. Their toxins are invariably alkaline, okay, not acidic. And so an acid should be applied to neutralize them and remove the pain. To do this, take a cotton ball and apply a little vinegar, then dab the ball into the affected area. So if a wasp or a hornet stings you, right, rather use vinegar, which is a household acid, to neutralize the sting. Bees, on the other hand, have acidic toxins in their sting. And so an alkaline solution should be applied to neutralize them. So if you have a bee sting, you take baking soda mixed with cold water and you make up an alkaline solution. So that is a base that dissolves in water, and you simply mix this up in a cup and then dip it into a cotton ball into the liquid. dab the affected area with the alkaline and the pain should instantly fade away. So bees are more acidic and you need an alkaline to neutralize their sting. Wasps are more alkaline and you need an acid to neutralize their sting. Just a little extra one, Calamine lotion. We've all used it for itchy bites. And funny enough, the best thing for like an ant bite that stings you is Calamine lotion. Because an ant sting contains formic acid. And the reaction between the acid and the base neutralizes the irritating effect of an ant's sting. Okay, other things you could do is you could soothe your stings with an ice cube, a cold washcloth, and try put some Calamine lotion on afterwards as well. Okay, and to end off, some of my favorites. I hope you're starting to understand my little cartoons and it's helping you to enjoy science that much more, and these little cartoons help you to remember certain aspects about the lessons that I've taught you. So, hey, litmus paper, why so blue? It was red dipped into blue. So what type of substance was this red litmus dipped into? It was dipped into a base. And this is basic humor, grade 7s. And this one, Calvin, oh, love it. Acids taste, and bases taste, yeah. Right, grade 7s. Have an amazing afternoon. Enjoy Earth Day. Take some time out. Sit in a quiet place and appreciate that everything you have around you. Appreciate the beauty of nature. Appreciate what's happening to our earth and how it's finding time to heal. Be kind to your siblings, and like I said yesterday, surprise your mom with a cup of tea today. Go on, do it now. Thanks for listening, grade 7s.